So the topics today, intelligent actuation. We're going to review the benefits of that intelligence. We're also going to compare the various types of actuation. They all have their purpose, and for the most part, the advantages outweigh the disadvantages. Review the energy and environment regarding actuation, and also how Kyntronics ties into all this, and how our actuator was purposely built to be this smart, intelligent actuator. That applies to pretty much everything we're going to be going through today. So overall, there's three main technologies out there: electromechanical, which are the screw base, roller screw, ball screw, etc. Those are usually tied to drive and controls. And you have the hydraulic systems, HPU constantly running, hoses, cylinders, valves, etc. And same with pneumatic systems. You have your compressor and various valves and cylinders going on and off. As mentioned, each one of these has their purpose, and some are a little more low cost and faster and more applicable to various applications out there. So they all have their purpose. Just as a note, in pneumatic systems, 120 psi-ish is the max psi, which means these are lower force, or just for example, 6-inch cylinder, which is a decent sized cylinder, only does 3,000 pounds, and for a hydraulic system, it does close to 85,000, over 40 tons. So obviously, hydraulics is known for the larger loads. Pneumatics are the smaller loads, and the cylinders do get large. So just looking at some of the hydraulic and pneumatic schematics, you see a lot of similarities between these two. Cylinders, various valves, solenoids, filters, and pumps. Different kind of world for both. What you don't see is a field bus, communications. Yes, you can grab some of that data and send it back. A lot of times it's analog. Some of the higher end systems do have some communications, but for the most part, most of these systems don't have that, those capabilities. And control and precision is also a challenge. This is a quote from way in the past: if you can't measure it, you can't improve it, which is going to be part of the theme today. So why intelligent actuation? What's the benefits of them? Just a few things up here: increase productivity, increase quality, increase efficiency, and overall, all those things wrapped together is going to be increasing your margins and increasing the total profit for the organization. And intelligence brings you there. So I won't get into our solution. That's going to be a little bit later, but overall, our intelligent actuation solution, named the SHA, referenced in this presentation, as well as other places, Smart Hydraulic Actuation. Excuse me. It's purposely designed for intelligence, designed with many sensors on there, position sensors, pressure sensors, etc. We can get into that a little bit later, but it's purposely built for what we've been talking about today. So why intelligence? What are the benefits there? So these are just some of the topics we'll go in a little more detail here in a little bit. So productivity increases, OEE, process monitoring, PM. Of course, you have the recipe management with intelligence. Field bus connectivity, yeah, it's pretty well typical these days, but some people take it for granted. There's a lot of information that can go back and forth between the drive and a PLC for intelligence. The simple PID control and tuning is what the intelligent actuator. Again, this is compared with non-intelligent things out there. A lot of things like hydraulics and pneumatics. Synchronizing hydraulics is a challenge. It's relatively easy with the intelligent actuators. Connect them together. A lot of testing applications have gone down our road to replace hydraulics, just because they can easily set it up. A lot of data is available, etc. You can adjust the machines need remote support. So anywhere in the world, you can connect from anywhere in the world. and help support with the intelligent actuators, dig in, look at graphs, tuning, etc. Analytics and reports as well. So as I mentioned, we're looking into a little more detail on these. So productivity, OEE, the overall equipment effectiveness. This is a powerful tool. It's made up of 3 categories: availability, performance, and quality. What does this do? It measures the overall effectiveness on a particular machine, not plant, but machine itself. So if you have 100 machines, you should have 100 OEE ratings for each machine, and each machine is going to be different, telling you a different story, and each machine, for the most part, should be dug into understanding why is the numbers a little bit lower than other machines, and through Pareto's, etc., you knock one off at a time, and you keep on increasing your overall rate. So availability is one important category. It measures the unplanned and planned downtime. 100% is always running during planned time. Downtime's a big part of measuring and cost. Performance machines, it measures the machine's performance capability, your max output, max speed designed to. 100% is running as fast as the machine is designed for. A lot of machines don't run there, and sometimes it's the machine's issue. It's not designed to do it, or various things, but that helps you. The numbers will help you dig into what's going on. Quality, again, that measures defects. 85% is world class. That's an average of 95% for each, which is very high. 60% is typical. And the same thing, again, the theme today is if you can measure it, you can improve it. And if you can improve it, you're going to increase your margins, increase your throughput. So process monitoring and preventive maintenance, this has been around for a long time, decades. In fact, when we first field buses were introduced with Data Highway Plus and various other ones out there, thought this was going to revolutionize things, and it really hasn't. There's some resurgence today with the cloud and just collecting data, motor, current, torques. So if your particular product that you're running requires, let's just say 30% torque to run that product over and over again, and one day it's taken 20% more, 20% less, there's something going on. And instead of making scrap, there should be flags raised to stop the process and dig into it. Those are the type of controls that can help you, minimize scrap and minimize downtime. Tooling changes is another one. You can just keep on monitoring various. You can know when tooling was made, monitor current, torque, various things, validation, quality. Again, the throughput. All of this is available with an intelligent actuation solution, intelligent devices out there give you these capabilities for process monitoring, as well as the OEE and the other topics we're talking about. Machine control, field bus, again with that connectivity just to the PLC, just a single wire plugged into the drive itself that controls the actuator, and give you the target reference, can give the feedback back to the PLC and upper level devices out there. You can easily set things up, easily change things on the fly. Again, you don't have those simple connectivity, simple adjustments with the hydraulics and pneumatics out there. Testing environment, gathering that data is really important. You can add and remove a section very easily with intelligent actuators, not so much with hydraulics and pneumatics. When I say simple PID tuning, that's just a reference feedback error. With hydraulics, they can't use the simple PIDs. There's many more variables involved with heat and hoses expanding and valves turning on and off, and a very complex control. This simple PID is used is a nice benefit with the intelligent actuators. Synchronize, another thing. Synchronizing hydraulics is a major challenge. And with our world, intelligent actuation, synchronizing 2, 3, 4, 8, doesn't matter. Again, with the field bus, high-speed field bus, you can do that relatively easily. We already mentioned the remote support. And all the previous slides rolled up into higher level MES, MRP, ERP systems, can roll up the OE for the plant. Machine 1 is doing X, machine 2 is doing Y. Well, you know, understand what the differences are. You know, garbage in, garbage out type thing with data, of course, but when you're monitoring some of the data, again, from the intelligent actuators, it'll tell you what's going on in the machine, give you the validation on the parts, even the recipe management. You can do that at your desk, set up a new part, set up a new process, speeds, positions, accels, decels, download it. You can upload things from the intelligent actuator. All those things are available to, again, increase your productivity, increase your quality. And a lot of people take it for granted. You have to do things manually with test reports for hydraulics. It becomes challenging. That's why our actuator is very applicable for the test world, providing those reports. Sometimes it's just a press of a button, you get all the data needed for the military aerospace, which require ATPs and reports, ATRs. Just a quick comparison from EMA and hydraulics and pneumatics, and we'll talk about our technology after going through this. So for the EMA, again, that's the screw-based technology, roller screws, ball screws, etc. It's like connectivity is there. It's a nice advantage. We talked about that. You have all the data available. Precise control, power on demand. We'll go through that in a little bit, a little more detail. And it's configurable. It's nice. You can change things on the fly. You don't have to get out with screwdrivers and wrenches to adjust flow meters and flow valves and things like that, as well as being environmental friendly. That's very important today. Some of the disadvantages with electromechanical, you know, it's a fragile design. They got to avoid shocks, avoid side loading, metal wear. You know, there's a finite life. Metal wear it affects that life. Sizing the actuator appropriately is important. Maintenance, if you don't do the maintenance, it affects life. So there's a theme going on here. Life is a finite life with these devices. Ingress protection, especially when they're running, that affects life. They're expensive to perform accurate control, force control. So that lacks some intelligence. Even some hydraulics have more intelligence with force control than the EMAs. Our solution has force control built into it as needed. For the EMAs, they get very large and expensive when the loads get larger. Limited configurations to fit in the machine. We'll talk about that a little bit later. Requires a brake. Again, with our product, we do not require a brake. And it's difficult for stored energy purposes, for the fail-safe worlds out there, valves control and things like that. It becomes very costly to provide that stored energy. Hydraulics, it's a robust technology, high force density, fluid characteristics. We'll talk about that. Shock loads are not a problem with hydraulics. Decent IP ratings, and they have the ability to store energy. Of course, we're all familiar with the disadvantages, the leaks, the noise, the hazards, and environmental issues going on out there. Continuous running motors, they're noisy, very inefficient. It takes a lot of upfront cost to design, implement, install, and support the hydraulics out there, of course. Challenge to reconfigure. The controls are a headache and a challenge. You can easily just do a velocity control up and down. It's not going to have any problems, but you want to get a little more sophisticated. It becomes a challenge. Lack of hydraulic experts. The youngins coming out today, they're not all that interested in hydraulics. Sometimes they think about it being an antiquated technology. And connectivity challenges, of course, we mentioned that. Again, as I mentioned, they have the EMA, hydraulics, and pneumatics. They all have their purpose, and they're all out there performing, and they, for the most part, perform very well. Just they have some challenges as well as the advantages. So pneumatics, going through those, low cost, simple movement, uses air, which is plentifully available today. Safe, clean, reliable, air is not flammable, just a bang bang, low cost solution. Nice, nice solution out there. Some of the disadvantages, challenging to control. Air may not be available everywhere. It is inefficient. The lower forces type thing and the connectivity. So just an infographic on what's going on in comparison between the SHA, our product, EMA, as well as hydraulics and pneumatics. Won't get into all these. The data collection, of course, the SHA and EMA are very good and somewhat challenging for the hydraulics and pneumatics. This will be available on the website. You can hopefully click on this link and get more information on the infographics as desired. So energy environment, the hydraulic power unit runs continuously at a very low efficiencies on average in that 22%. The EMA as well as the SHA, our product, they only run when commanded. For example, if you have an 8-inch cylinder and at the load zones only 1 inches at the end, so you run 7 inches at low power, do the work, the 1 inch, and then you retract another 8 inches. So for the total 16 inches of travel, you're only doing work on a 1 inch, and you're only using power for that work at the 1 inch. Again, compared to HPU, it just runs continuously, provides the power, and solenoids open and close and move cylinders as needed. Again, the power on demand is very, very effective. You can see some of these numbers below here. You have a 10 times example here, 70% efficient SHA compared to a 22%. A lot of savings for energy. And as a note, the SHA can be up to 50% more efficient than the EMA. So you have the SHA being more efficient and more effective than the EMA over time. I like the statistic, and this was surprising to me. 1 to 2% of all U.S. energy is used in hydraulic systems. So there's a lot of low-hanging fruit to update hydraulic systems, make them more efficient, or replace them with our products. Just a small increase in efficiency equates to a lot of savings out there, not only monetary, but sustainability savings. Won't get into too many details here. Again, this is on our website. Feel free to go there and check it out. There's a link at the bottom. This is just comparing our product to hydraulics. You have various categories. The environmental category, this has to do with the hydraulic fluid index of fluid going into the plant and going out of the plant, disposing of. There's a lot of costs associated with that. Energy usage, we talked about the floor space, of course, the human factor, and then the downtime. All these numbers can be substantiated. Again, check out the website. There's links to various other sites out there, fluid sites that provide us this data. And as you can see, there's significant savings just in this example. So electromechanical, quick little reliability comparison. Of course, they are more efficient than hydraulics and pneumatics, and they're also more fragile. They have a finite life. You can see in the video on the right-hand side. This is just an example of a press, but all the gears come together at the same place, at the same time, when you're doing that work. And that leads to finite life, failures, and things like that over time. Again, that's the metal-to-metal wear, challenges with the ingress protection as well. So I won't go into a lot of this more detail more. We've already covered it, but just wanted a high level, do a little focus on these two technologies, EMAs and hydraulics. We went through the benefits, ease of control, power on demand, robustness of hydraulics, and then the headaches, the challenges, metal wear, and environmental challenges. So that's the what if. What if you can combine the benefits and eliminate the challenges? And that's what we're doing. So we're providing an intelligent solution, eliminating the headaches with the EMAs. There's no metal wear on our system. There's no hoses, no filters, minimal maintenance. You have the power on demand as well as the force density. So that's the magic of our product. It does combine the benefits while truly eliminating the headaches out there. So how do we do that? Some of you may be familiar, some of you are new to the product. So quickly, product is a standalone hydraulic actuator. There's no air. It can be used in any orientation. You have a servo motor connected to a gear pump. You run the servo motor in one direction, it pushes the piston up. You run the servo motor in the other direction, it pushes the piston down. It's that simple. It's a very intelligent actuator. Hydraulic fluid, again, combines the benefits of the EMA and the hydraulic systems out there. So intelligence, it's what it was built for. The actuator, there's all position sensors on there. You have your servo motor, you have your pressure sensor. Again, there's no actuator out there that has all this capability built into one standalone actuator. Others can try to meet the force using torque, but we were actually measuring it. Force equals area times PSI. You know the PSI, you know the force. And all that data goes into our all-in-one software standard package. You can do force control, position control, or a combination of both. And that data can calculate all the necessary items, the PM, the OE, or whatever you need. And that data is available through the network to the upper systems as desired. So I mentioned earlier about the fluid characteristics. This is a nice advantage of hydraulics in this standalone product. The EMA itself, parallel is pretty much standard, or you have the inline. Do anything else is a major challenge, if not impossible. We're just moving fluid. So if you need this spacer to be a little longer to fit into a machine, you can make this a little longer. Same thing here. So we've done all these to fit in the machine. So that tells me that the EMAs have some challenges fitting into the machine with these limited configurations. Again, we've done all these and many more. And it's just moving fluid around, which is a nice characteristic of hydraulics. Again, combining the benefits. So advantages, the field bus connectivity, of course, gives you all the advantages that we talked about earlier. Gives you the PM, the OEE, high level validation, etc. There's no hoses, no threaded connections, no leaks. It's a very quiet solution. Not a problem with shock loads. As mentioned, no metal wear. Hardly any maintenance. Very reliable. Versatile configurations and flexible control. So for this presentation, it's about intelligence. Our actuator designed around that intelligence to have all those sensors available to provide you more data, more efficient processes that overall provide you the more improvements and the savings for your system. Again, if you can measure it, you can improve it. It is also a very good go-to electric solution out there, replacing hydraulics for a more sustainable solution. And that's the conclusion. Any questions?
Carl, I see a question coming up about the IP ratings and whether we have washdown duty
So out of
ratings available.
Yeah, so out of the gate, it's IP65. We've done IP67. We've done higher. We can also do the washdown as needed. Those are all options, of course. They're added costs, but again, it's something relatively easy for us to do, and that is available.
including epoxy coatings and whatever's required for your specific environment.
Right.
Yep, and special seals for the rod seal and whatever your application requirements are, just make sure you get them to us, and we have the ability to package this thing up to make sure it withstands those environments. Another question is, do we have internal LVDT feedback available?
Yes, it can be gun drilled into the rod. We've done a lot of those. So you can have external or internal as desired.
And that's the beautiful thing about cylinders, by the way, is that is a standard option. And it's not real pricey when you have shorter lengths, let's say under 24 inches. It gets a little pricier when you start getting into longer lengths just because of what's involved in gun drilling the rod. But it is a standard option available, and we'll be more than happy to quote that for you. And that obviously helps shrink down the package and eliminate the likelihood that somebody's going to damage that externally mounted linear feedback device. Let's see here. So we've got who our contacts are for quotes, and we'll certainly make sure that we respond to any inquiries that you send us by email. But you basically have sales@kyntronics.com is your catch-all. Feel free to use that, and we'll get back with you as soon as we can there. We have another question about the food application, stainless steel or white epoxy for IP69K. And Carl, if you want to address that.
Yes, those are available. You can do stainless steel, of course. It's, there's some costs associated with that. So we can provide that as needed. Your special epoxy coating. We've done epoxy coatings before, so we can do that as well.
Yep. And then back to this whole intelligence theme, we've got a question about how can position and force data be exported for data storage and processing? And that's an excellent question. And that, again, is the beauty of this smart actuator and the fact that we've built the sensors in to be able to very accurately not only control the position, but then validate that we're in position, send that information from this intelligent drive over to a PLC or even to an HMI if there's not a PLC in the architecture. But so all that intelligence is built into the servo drive that's controlling our servo motor that's turning our positive displacement pump. Same thing like Carl mentioned for the force is we build in a pressure sensor, which is a very inexpensive, tried and true, reliable device that can convert your area to force. And we'll do that calculation inside of our control so that you can very easily monitor it, validate it, basically timestamp it, whatever you have the capability of doing within your PLC and your HMI and your statistical control and data acquisition software, all that sort of fun stuff. And that's really what we wanted to emphasize today, is that we're purposely building these with those sensors on board to provide you with that intelligence to be able to do your quality validation for both position, force, speed, synchronizing speeds with other axes on the machine, whatever's required there. So hopefully we've covered some of that for you today. Do you have worldwide support for OEMs? And of course, the answer there is yes. And we're working with channel partners, of course, throughout North America as well as internationally. So let us know where you're looking for your support, and we'll gladly work with you wherever you are worldwide. We have a question, can it run on its own, or does it need a PLC to run a simple machine? And Carl, you're welcome to grab that.
We've sold several standalone units. It does not need a PLC. You can provide, so we also have an option to provide like a little touchscreen or push buttons or whatever you want. But we do sell a touchscreen that is 7-inch touchscreen that can go on a panel or on our front of our enclosure, and you can run the whole system through that, set it up. And grab data.
Yep. So we're using an intelligent device, a servo drive, if you will. It just so happens the one that we're using that's available commercially off the shelf. It's not a proprietary product, but it has a coprocessor on board that does all the software that a PLC also does. It's in your what we call standard programming languages, so you can take full ownership of that. We can put an HMI with it, so we can do your motion profile inside of our quote unquote smart device, so that it's pre-programmed, ready to run your application when you take receipt of it, factory tested to provide the force and the position that you're specifying, all that sort of important stuff. So that's
So
one of
in
the options
summary,
in the,
yes, you
go
can
ahead.
run it all by itself.
It all by itself, and then likewise have whatever field bus protocol on board to talk to your PLC or your industrial PC or whatever it is that you're monitoring your production and doing all that important overall equipment effectiveness tracking. And then the last question that I see, although wait, we might have new messages as well. What maintenance is required? Carl, you want to handle that one?
Yeah, so the maintenance it's pretty much maintenance free depending on the actuators. Some of our actuators have fans on them, and all we do is recommend you review those and you blow the fans out and you just take a look at the actuator and make sure there's nothing abnormal going on, nothing hit it or nothing damaged it. And so it's pretty much maintenance free. The oil does not need to be changed. And it is pressurized, so you don't want to open up any ports at any time, and otherwise you're going to have things squeaking out.
But
So
when you say pressurized, Carl,
it's a low pressure, maybe less than
Yep.
30 psi.
Right. So there's no stored energy in the system. That makes it very safe, especially compared to pneumatic and hydraulic systems that are constantly running and have the motor energizing to a certain value, whether that's 1200 or 3000 psi. The only energy that we generate is when you're actually commanding motion and the motor is turning the pump to make the rod move. Otherwise, no stored energy there. The last item on the maintenance question is that we do have one wear item, and that's our rod seal, and we very conservatively rate that for 50 million inches of average travel. And then because you have the intelligent feedback device built in on the rod, we can track the number of cycles, be able to tell you when that rod seal is coming due for replacement. And so you can do all of your important predictive maintenance, that kind of stuff. But other than that, really, it's designed and built purposely to be maintenance free. The next question, are there brakes for operator safety conditions or position holding for extended periods of time? And Carl, I'll just jump in to say that's, again, the beautiful part of using a hydraulic circuit, which we're using a cylinder, and the simple method of stopping fluid flow using a inexpensive check valve is something that, provides all of that full force holding capability without having to use a mechanical brake or something that's eventually going to wear out and need to be replaced, not to mention the fact that it's big, takes up space, it's expensive. So a simple hydraulic circuit with a check valve is a standard procedure for us. We can put those on the extend, on the retract, or on both. We can use a solenoid to open and close those to be controllable as you need to. So that's a great technique there. That's a nice question. Is there a new RFQ form to use? There is actually on our website under support. You'll find a link.
Mark already put it on the chat.
Oh, fantastic. Great. Question regarding food grade oil. And the answer there, of course, is yes. We can use whatever specification of fluid your customer needs. We most likely will want to verify that, get all the specs on it, put it in our cylinder to test it and make sure that it's compatible with all of our seals, all of those important things. But yes, so food grade, fire resistant, eco-friendly, all of those important considerations are available with our designs as well. And thank you, Mark. I see the link there. And how are we doing on the questions? Is an electronic proportional relief an option, or is it just the master relief sufficient? And Carl, you want to take that one? It's
Yeah,
really
sure.
talking about.
So,
Yep.
yeah, so our standard every actuator has a relief valve, mechanical relief valve, both on extend and retract. It's mechanically adjusted, and of course you can get a electronically adjusted if needed. It's just an option
Relief. So in other words, we're manually setting the relief valves for some force rating most likely just above what you're specifying you need this thing to do. So it will be built in with a quote unquote equivalent of a mechanical clutch. But the beautiful thing is these valves are just going to allow fluid to flow when you exceed the rating of the unit, and therefore protect it mechanically, protect your machine mechanically without having to have a wear item like an actual clutch in it. And like Carl's suggesting, if you need us to be able to adjust those settings automatically, we can build that in as well using solenoids. And then there's a question about software cost. In the case of the drives that we're providing as the all-in-one, that software is all built in. There is no additional charge. The software to access or take ownership is likewise included in the price. So there's no real software cost on our end. And then, of course, if you're using anybody else's brand of motors and drives, because any motor or drive will turn our pump, then you'll be dealing with whatever the software that comes with those products. And by the way, just to cover this point too, if you're going to be specifying brand X, Y, or Z of motor, you're welcome to send that motor to us. We'll mount it for you. We'll spin test it if we're able to run that motor, which most of them we can, and we'll verify that everything's working properly before we ship that unit with your motor installed as well. And that's just a standard part of what we do. The next question is there any steps noticed in a pressure trace when applying to a pressure level? Concern is the gear pump causing noise in the signals. Carl, you want to take that one, Mr. Double E?
Yeah, it's a good question. This actually has to do with, I think John is referring to the gear and the pulses from the gears. So it all depends on the speed that you're looking for. Through our higher speed pumps, you're going to get some steps. They're very minor. And if force is very important, we then usually go with a lower speed pump if speed isn't that much of a concern, and the steps is very minimal, if at all. It's a very smooth force control.
So the translation for my mind is that give us your specs, tell us what you're trying to accomplish. We'll be happy to help figure out how to do it for you. And if we can't, we can't. We're certainly not all things to all people, but it's amazing what we can actually achieve with this thing in terms of good torque resolution and force control and all those important
all
things.
The units we've provided, we have not had any issues with people saying, hey, this is unacceptable. So it's very smooth.
There you go. What is our position accuracy?
It's we advertise 1,000 plus minus. We've done better. We've done it in tenths. So that's
plus or minus 0.001 inch is what we call our high accuracy. If you need something better than that, please come talk to us and we'll figure out whether we can do it. And otherwise, you're covered. Is there force control or is it position control only? And Troy, you might have missed earlier that we do have force control as a standard option using a simple pressure transducer, pressure sensor in our manifold, and gives you that signal to be able to control force very accurately and repeatably down to what we call less than 1% of your total force value. And if you need something better than that, we can help figure out how to do that as well. And that obviously keeps the architecture very simple. You're not forced to use a load cell. If your customer or your application is already using a load cell and you want to stick with that, then that's just another feedback signal that we can bring back into our smart device, our intelligent actuator, and we can close the loop around that to use that for force control.
The
Go ahead.
Point there is that we do position with force limit. and that's a very popular mode in our standard software. Actually, we have the standard software is applicable in our drive that Mike mentioned, as well as Rockwell drives for the AOI. But our standard software position with force limit, meaning you're going to go in towards a particular target. If a object is in the way, let's say the part, and you want to switch over to press 5,000 pounds, it's going to seamlessly switch over to force control, do the 5,000 pounds. At the end of doing the 5,000 pounds, it'll then go back into position mode and retract. So
yeah, and you have all the intelligence built in to validate that, right? So you can verify that you got to the right position with the right force, timestamp that. Traceability is very important to a lot of these customers for recalls and what happened, what went wrong, covering their tracks, going back and, verifying all that important stuff that these intelligent actuators provide you the capability to do. So moving along, what is the longest stroke we can offer? That's again, the beauty of cylinders, is that you're not paying this huge premium for the longer stroke lengths. And really there is no physical limit for how long we can make these things. I think we're building
10 feet actuators. We've quoted longer ones.
We're building some 12 footers right now, right? So
yeah, so we've what we do, we do the calculations for the buckling and the bending and all those sort of things. We'll beef up the rod and do what we need to do to provide the stroke as needed.
Yep. And just to add to that, we've recently been getting a lot of inquiries for long stroke lengths where they want to use telescoping cylinders, and there's no reason that we can't use our intelligent, totally sealed power units to control those telescoping cylinders that you want the thing to be able to collapse to a little bit smaller profile when they're going out 12, 13 feet as well. So that's another option that's available to you. Let's see, did I miss anything? What is the repeatability for position control? And I think we kind of addressed that, but Carl?
Yeah, it's a repeatability and accuracy. It's in that 1 thou plus minus. So you can have that repeatability is actually usually more accurate.
Great.
More consistent.
And Mark, unless I missed anything, I think that got us through most of the questions. And I'm just going to put the email address sales@kyntronics.com on the chat window, so it's part of the permanent record there. Any inquiries that you send to that email address, we'll make sure that we handle and get back to you and follow up and support you as needed to make sure you're successful. And those are some really, really good questions.
Very good. Appreciate you guys' time. Thanks again.
Carl, thanks very much. Thanks, everyone.